What's up, party people? My name is Sunny Ray. This is the Sunny Ray Show. Oh my goodness, this will be like I think our fifth interview, and I swear every single one keeps getting better and better. This next gentleman, his name is Herb. He's done the thing almost nobody in this space has done, built an infrastructure business in a boring category and exited for $800 million. Before LiquidCool, he co-founded what became the largest owner of district energy systems in the United States, which is a business about moving heat around cities. Then he took the same physics into the data center where LiquidCool immerses server components in a sealed chassis of dielectric fluid and combines the efficiency of total immersion with the processor level cooling of cold plates. He has around 64 patents, sits behind this technology. It's my honor to bring on Herb. How are you doing?
Well, I'm doing pretty well, and I hope you are as well. We now have 72 patents, but that's okay. 64
Look at you. My
Yeah,
goodness, on fire. So, Herb, why should people care? I mean, connect the dots here, right? So, I mean, everybody's going crazy over AI, obviously, including myself. But how does what you do affect that, average listener who's using AI to build their business?
So AI is a software that sits on a platform of hardware. And the hardware that has been offered pretty much from the beginning is obsolete. There's a famous story about the horse manure crisis of 1894, where the London Times published an article that said in 1894 that said, unless something is done within 50 years, the city of London will be under 9 feet of horse manure. And of course, this was true for all the major cities. So a conference was called International Conference in 1896 in New York City. And they couldn't solve the problem. Meanwhile, 13 years later, the last horse-drawn trolley in Manhattan was retired because while these folks in New York were thinking about horse manure, Henry Ford in Michigan was thinking about the horse. That transition, that whole world flipped in 15 years. That's happening right now in the data center world because air can't do the job anymore. It was always a terrible idea from a physics and engineering point of view. Now it can't do it. So liquid cooling is becoming necessary. And that's in the headlines because it affects water supplies, it affects power supplies. The amount of energy and money going into data centers is incredible right now.
Tell me about it. So, Herb, let's rewind a little bit. You spent 35 years moving heat around cities before you moved it around servers. What transferred and what did not?
Well, when the district energy system, so we own the downtown energy systems in 11 cities in the U.S. Boston, Baltimore, Kansas City, St. Louis, Los Angeles, with 11 cities. And we had 15 central utility plants to do that. We sold the company, my friend and I, for two reasons. One is we got an offer we couldn't refuse, but two, I became concerned about whether that was the best way to move heat around, frankly, in the most efficient way. And I think right now I'm working on a different kind of approach to solve that problem that's much more efficient. But anyway, so I became interested in this problem of what I saw as a huge inefficiency of in data centers. We sold the company successfully. I call it exiting with dignity. And my friend and I did fine. And so the reality is I could have retired. My wife tells me I should have retired. But you don't have these change the world opportunities that they don't come along that often. So my focus since then has been basically solving this what's becoming an enormous problem of how do you support this software industry efficiently and economically? And that's what we think we have done or are doing, frankly.
For years, total immersion was called impractical, right? So what was actually wrong with it, and what did you fix?
Well, when people think of immersion, they think of tanks. They think of a bath in which it's a horizontal bath in which you insert servers or electronic boards, really. That's not, it's more efficient than air, but it's not very good. It's inconvenient form factor. It's what I call a horizontal solution in a vertical world. Maintenance is a mess. And frankly, it's a what we call in our bulk fluid cooling. So you're basically putting it in a bath, and all the components are touching the bath at the same temperature. So there's a little bit of tweaks and so on, but fundamentally, it's not the right answer. The other problem is it doesn't do a good job of targeting the hot chips. So what's really getting traction right now are what we call cold plates or direct-to-chip cooling. And so what that is it puts a heat exchanger on top of the processor inside the chassis of the server. And it removes the heat with a closed circuit loop of liquid or refrigerant. But that leaves about 30% of the heat still to be removed a different way. So every server has now two cooling systems, which is unnecessary and expensive. What we do is we combine both of those in a single solution. And what was then called NREL, the National Renewable Energy Lab, and now called the National Laboratory of the Rockies, tested our technology in its Golden, Colorado data center for 2 years and calls us the gold standard for cooling data centers in connected buildings. Lawrence Berkeley tested us for the US Navy and said that we're 30 times more efficient than what the Navy does in tropical climates. It's just the right answer. I call it the LED of the data center world. You have in lighting, there was incandescence for 100 years, 90% heat, 10% light. Everybody who was knowledgeable or cared knew that ultimately light emitting diodes, LEDs, would be the right answer. But for a period of years, maybe 5 or 10 years, this whole compact fluorescent light bulb came along. It was basically these spiral light bulbs anyway, factories were built, patents were filed. When was the last time you found one in a hardware store? Because it was a transition technology. I like to think that direct-to-chip is a transition technology like that. It'll be around for a while, and then it's not going to be there at all.
Right. I don't quite get. So why the chassis rather than the tank? What does sealing it at that level buy you?
So if you use a standard chassis in a standard rack, it's a standard size chassis in a standard rack that you have already in your possession if you're a data center operator. You can literally replace one server at a time. If you were we did a study for a federal agency in the US that had 115 racks. Now, this was before direct-to-chip, so the economics aren't quite the same. But at that time, one of our servers was equivalent to four what was then Dell servers in terms of compute power. And they were replacing their equipment every 5 years. So the idea was that they would, every time they were going to buy equipment and spend money anyway, they buy one of ours for every 4 of the other ones they would have bought. So they were saving money on the upgrade because it didn't cost 4 times as much. But they were also saving money on the servers they replaced on energy. And at the end of 5 years, they would be completely converted. So it was astounding, the economics. The number of racks went from 115 to 25. We reduced the space requirement by 70%. The energy was cut less than half. But the bottom line is they didn't do it. If they had done it, we wouldn't be having this conversation today. Because we would have the demonstration at scale that everybody wants to see, but they didn't. But the effects are: we reduce the space by 70%, reduce the energy by 40%. We eliminate the need for water for cooling servers if it's cooler than 110 Fahrenheit, 45 centigrade. And we also reduce maintenance by 90% because none of the equipment that you would otherwise need is necessary. It's a huge impact.
Herb, I talk to like 20 founders a day, but it's rare that I get to speak to somebody who's had like a significant exit, like you said earlier. So you co-founded a district energy business, right? That sold for around 800 million. What did that teach you about infrastructure businesses that maybe a software founder would never learn?
Well, that's a good question. I mean, that particular company the equity for that company was the Harvard Management Company, which was the Harvard Endowment Fund. And they did great as a result of the sale. My partner and I had a carried interest in the business, so we did pretty good considering what we had started with. But the reality is, it's a different kind of a situation because those are fixed assets that already existed. Long-term contracts with companies and businesses in downtown areas that couldn't open their doors without you, so they had to pay their bills. It was a utility offering, frankly. The situation with LiquidCool Solutions is the opposite. It's basically it's a technology for a foundation, but you have to start from. Well, you don't have to. You can use your existing data center and existing racks, but it's a different kind of concept. We're selling equipment. We're not basically selling contracts for long-term supply. So it's a whole different business.
Everyone talks about compute as a chip shortage. Can you make the case that it's actually a heat problem?
It is absolutely a heat problem. I mean, right now, all the components, including chips, are in short supply, all the way down to the power product. I mean, getting transformers, getting backup generation, getting switch gear for data centers is a long-term purchase situation. But heat is the challenge. Getting rid of the heat and the noise that accompanies with it if you're using air. Air was always a terrible idea. It was just how it ever happened, I can't imagine, but it did. I mean, air is an insulator. Early in my career as an engineer, I used air to keep heat from moving around. It keeps heat from moving. It's an insulator. It has no thermal mass, and it doesn't conduct heat. So the only way you can move it is with fans. And fans use a lot of energy. Just by way of example, we looked at a data center, and that was built by what was then Facebook in Iowa in 2016. It was a hyperscale data center. 30 megawatts was then considered hyperscale. Now you're talking about a gigawatt, 300 megawatts. It's crazy. So 30 megawatts now is considered an edge computing center. But to move the heat around that data center from the central air handling system and chilling system, 1.5 million cubic feet of air per minute. 1.5 million cubic feet of air per minute. The fans in the racks, which we completely eliminate, another 5 million cubic feet of air per minute. Wow. They're moving 6.5 million cubic feet of air per minute. Can you imagine the amount of heat and energy that takes? It has to also be removed from the data center. It's ridiculous. But that was the standard until fairly recently.
Herbie, if cooling is the constraint, who actually captures the value? The chip makers, the data centers, or is it the cooling companies?
Well, the data, if you build it right, just by way of example, today in the U.S., the infrastructure to build a data center, not including the IT equipment, is about $13 million per megawatt. So if you have a 30 megawatt edge computing center, that would be 30 times 13, almost $400 million, over $400 million. In our technology, it's half that. So you save money up front, and you save money virtually every day you operate because you're not using all that energy to move air around. And if in many cases, if the temperature outside is less than the 45 C, you don't need water either, which is one of the big headlines in many. I mean, the water situation is getting to be ridiculous. I live on Lake Michigan. Well, even in Lake Michigan, they're complaining about water use by data centers when we have plenty of water theoretically. But why do it when you don't have to? That's the question.
Herb, what is the water story? Liquid cooling gets attacked on water use fairly or not?
Well, liquid cooling in general, there's 5 forms of liquid cooling out there right now, including ours. There's basically rear door heating, which is bringing the heat exchanger right to the back of the rack in an attempt to reduce the volume of air you have to cool. It just makes the room smaller. But it has all the challenges, including of heat removal from chips of air cooling. Then there's direct-to-chip, which is getting some traction because it solves the urgent problem of cooling the hot chips. Then there's the immersion tanks we discussed. There's 2 phases. There's 2 types. One's a single phase, which is basically uses a dielectric liquid using bulk flow cooling for the most part. And then there's the 2-phase, which does solve the chip problem, but it's a pretty costly, and also there's all kinds of challenges with it, including some environmental impacts and also the health impact so we can talk about that in a minute. But the final phase, the final version is our rack-based immersion system, where all the electronics are immersed, but standard racks and standard chassis sizes. So you can actually replace a server one at a time in an existing rack. It takes about 3 hours to modify the rack. And as you go, you can, over time, when you're spending money anyway, you can basically upgrade your system.
And what breaks first in an existing data center that tries to retrofit to liquid?
Well, again, it's the challenge of cooling these hot servers. I mean, in the old days, a server chip might have cost a couple $100 and was pretty low power. Now they cost $30,000-$40,000 a piece if it's an NVIDIA server chip GPU, and so you don't want to make a mistake if you're spending that kind of money. The other consideration is that the servers are simply, even though it's not like software is a recurring revenue model, they charge you per seat. In this case, that's not true, but about every 5 years, a server gets replaced anyway, because it's technologically obsolete or it's failed in the field. And so there is a constant churn because people are upgrading all the time.
Yeah, that makes sense. Herb, 64 patents is a real portfolio, or so you said 72, I think.
72, yeah. You're shorting me on that.
Yeah,
72.
yeah.
29 are U.S. and the rest are outside the U.S.
Does IP still defend anything in a market moving this fast?
Well, it's interesting. I mean, the patent portfolio, we developed the patents around products that we made during the development phase. We shifted from science to sales about 3 years ago. And now we have a catalog of products you can buy off the shelf, off our shelf. But we shifted, the patents came out of products we were making. There is a patent moat around our technology, which is pretty wide and deep. We've been tracking 7 infringements. Some lawyers make their living out of going after infringers. That's not our business model, but that's always out there, I think, in time. But right now, we believe that we have the right answer, and we have a patent portfolio that provides a moat around it if somebody wants to try to copy. We even have patents in China, where obviously they'd be difficult to defend.
Hey, Herb, you handed the CEO job to someone else and became vice chair, right? So what does it take to let go of a company people told you was too weird to work?
Well, this is during the science phase. It wasn't voluntary exactly. I was basically promoted without my full assent. But during the development of small companies, you've got a lot of voices on the board and as among investors. And somebody wanted to put in a friend, and I was opposed to it, frankly, but they did, and here we are. I think it personally slowed down the company uh, growth, but it happened, and that's in the rearview mirror now.
What do you believe about this industry that most people in it do not?
Well, a lot of people, of course, would like to close the door. The genie's out of the lamp. AI is here. It's going to be a challenge to deal with it because it has so many potential implications, some of which are great and some of which are quite serious. I think the reality is we have to figure out how to deal with it because it's not going to go away. And the support for it, the equipment behind it, is a whole different. We have not seen this before, but the world is changing very fast around what's AI. And as you've seen in the newspapers fairly recently, the genie is not only out of the bottle, but it's caused some damage. It's like the old Hal in 2001 movie, where the computer basically just took over by itself. Well, that's actually happened in several instances in the last 3 months. So it's concerning, and we have to be very careful, no question about it. And you have to be careful what you read and look at on the screen because a lot of it is not real. Some of it's just ginned up by a computer program. Maybe this is. You don't know.
Yeah. This is actually I'm an AI itself. So
Maybe I'm ginned up by a computer program. I don't know.
it could be, and we are probably living in some sort of holographic illusion. What advice would you give a founder building, physical infrastructure in a software obsessed funding market?
Well, it's hard. It's the challenge is it's expensive, and the reason it's expensive. There's a number of reasons, of course, but one reason is because you're fighting large companies that have an inertia to them. There's not a great desire to change if you can avoid it, and we can talk to Kodak about that. We can talk to Xerox about that. The truth of the matter is that large companies that don't put their toe in the water on new ideas are going to die because the existing technologies, whatever they are, including ours, will ultimately be supplanted by someone else. And we have to be prepared for that. One way of being prepared is to try it. I mean, our business model right now, because data centers are so expensive, is to do pilot projects. We did a pilot project with electric utility. They bought a small rack of our equipment. I think they paid like $60,000 for it, US, and they installed it in the turbine room of a coal-fired power plant. So it was a pretty hostile environment compared to most data centers. We set it up in 3 hours. It was a demonstration project. The purpose was to see how efficient it was, but also see how easy it was to work with, because it's good to read about these things in laboratory reports, but until you kick the tires yourself, you're not convinced in many cases. Anyway, they tested it for 4 months. We're convinced it was a game changer. So what they did, first of all, we bought it back from them. I think they paid 60, we bought it back for 50. So they had a small investment. If we didn't do it that way, the test never would have ended. So they have to have some flesh in the game in order to move things along. They ordered 40 servers for their fleet. And the servers they ordered, they said, okay, we don't want what we tested. They were low power servers. Here's the server. Here's what we want. We want this processor. We want this storage. We want this memory. So we packaged those off-the-shelf storage, memory, and processor, delivered 40 servers, and now they're installing them in their fleet as their processors as their servers come up for replacement. So they're spending money anyway. They've got a $10,000 investment in the test, and they've concluded they'll save hundreds of thousands of dollars if they replace what they're currently doing on schedule with what we can provide. So we're looking for more opportunities like that.
Herb, if someone watching this and takes one thing away, what should it be? And yeah, I guess we'll land the plane after that one. Thank you for being such a great guest.
Thank you for asking. Well, I think the one thing I would leave everybody with is the change is definitely coming here, and you can see it in the stock market. You can see which stocks are going off the charts and which ones are not. And anybody that clings to the old idea is making a mistake. Air cooling is in the rearview mirror, period. And so there's going to be other offers with different kinds of solutions, and some are going to be good and some are bad, but you're going to have to deal with the change that's about to occur.
Love it. Well, I mean, it is kind of funny though that we got so far with just air. I mean, and you're right. In engineering, I remember it was usually used as an
the engineering term for that is it's stupid. That's the engineering description of cooling for it. It's a stupid thing to do, but we've been doing it and spending a lot of money on it.
Yeah, it reminds me of I went to University of Toronto, and we're actually a lot of this like AI is coming out of, right, like Minton, Lilia. And they have this funny story. I don't know if you've ever been to the campus. They've got this library called Robarts Library. It's shaped like almost like a pelican. It's ginormous. 4 floors of the library don't have any books on them. Why? Because when they designed the library, the engineers forgot to take into account the weight of the books, and so the building is sinking. And so, yeah, I'm kind of reminded of, of that, which are related to what you're telling me. Herb, you've been an awesome guest. I really, really appreciate it. Very inspirational story. And I hope the listeners got a lot out of it. Thank you all for listening live, and everyone else as well. Thank you for tuning in. Herb, hang out for 1 minute. I'm going to bring this stream to an end, and I'll see you on the other side.
Okay.